For this problem, we're going to apply gas laws with just generic stoichiometry. We have a reaction where we have a balloon, and in that balloon is a bunch of O2 and a little bit of CH4. CH4 is definitely our limiting reagent, but they're going to react, and we'll assume this balloon's made out of some non-flammable, reasonably insulating material. And it is going to heat the gas inside. What we will find is that after it reacts, the final temp of all the material inside is 847 Kelvin. Given this info, what is the change in volume the balloon goes through? So it had its original volume, it's going to have a new volume at a higher temp. What is that difference? How much bigger did it get? Pause here, see if you can figure out what steps we would need. We'll talk through that, and then we'll pause and try the problem. All right, if you're back, well, what's happening here? I'm heating up our balloon. So on the one hand, I've got some PV equals nRT. I've got a gas. It's going to have some pressure. It's going to have some temperature. It's going to have some volume. And there's moles. Well, I'm doing a reaction. There's so many moles of each of my gases, but those moles are changing. I'm losing some starting material. I'm gaining some products. So that balloon's composition inside, the gases in it, are not going to be identical at the end. I'm going to be missing some CH3. I'm going to be missing some O2. And what am I making? I'm making some CO2 and I'm making some water. What proportion and how much is going to be relevant to the size of that final balloon? So while we do have this heat change, I have to adjust for my reaction. What's that going to do to my balloon? How are my moles going to change? Given that, let's see if we can't solve what is the actual change in volume. All right, if you're back, well, if we think about it for a minute, let's talk about that mole change. For every one methane that goes away, 2 dioxygens will go away. As a result, for each time I do this reaction, I will lose 3 particles. And in the process, I will make 1 carbon dioxide and 2 waters. So I will make 3 particles. The net effect is the moles of gas in our balloon don't actually change, because we have the same moles of gas on both sides. A total of 3 on the left and a total of 3 on the right. Whatever we consume in the reaction, we will produce just as many moles of gas in the products. And so we actually don't have to worry about the moles changing this time. It is a concern when you do gas reactions. If you make less moles of gas than moles of gas consumed, you'll just have less particles bouncing around at the end. That will affect your calculation. We're lucky that in our case it's 1 to 1, well, 3 to 3. So what we really need to do is we need to find it. How big is this balloon? Well, there's a couple ways we can go about doing this. It's a balloon, so we can pretty much assure that pressure 1 is going to equal pressure 2. And we just said that our moles are going to be the same. So the only things that are changing here is that my volume and my temperature. Well, my temp is going up, and my volume will also go up. Really, we have a volume 1, temp 1 equals volume 2, temp 2 situation. My original volume, well, we're not told that. That's a problem. Can we solve our original volume? Well, I do know the moles of gases. Sort of. I know that I have 0.5 gram of CH4, and I know I have 50 grams of O2. I can find the moles of each of those gas. It is 32.00 grams per mole for dioxygen. It is 16.05 grams per mole for methane. 0.03118 mole of CH4, 1.5625 mole of O2. They are all the gases, and even though we lose some starting material when we make just as much product, so we're going to have this many gas molecules no matter where we are in this reaction. The total here is 1.5937 mole of gases. So for my initial balloon, I know the temp, I know the pressure. I now know the moles. I can solve that initial volume. My volume is going to equal nRT over P, 1.5937 mole, R 0.08206, atmosphere, liter, mole, Kelvin, 27 degrees, so 300 Kelvin, and 1 atmosphere. That original volume initial, 39.3 liters. So I know my initial volume. So we do V1 over T1 equals V2 over T2. My initial volume, 39.3 liters over 300 Kelvin is going to equal X liters over 847 Kelvin. So that was our final temp. Rearrange, X liters is going to equal 110 liters. That is volume 2. Now we were asked to find the difference, the change. So 110 liters minus 39.3 liters for a difference, a delta V of 71 liters. All right, 70.7. But rounding, we really only had about 2 sig figs in any of our original calculations, so we're going to have 2 at our end. 71 liter increase in volume. So if you have a reaction where your gases, you have amounts of them, we can solve the moles and the pressure. We can turn molecular mass and masses into the relevant info to finish this gas law.